Piano. Hello, guys. Can you hear me now?
Yes, we can hear you.
How are you guys doing?
Good. How are you?
Fine, thank you. So, Washington. Okay. So now, last week we finished confidence interval. This week, I'm going to show you we're entering a new topic. Let me show you from the announcement I made. So if you look at my announcement for this week, which is week 13, we're almost at the end of the semester. I'm sure you guys are excited. Okay. So this is week 13 announcement. Yeah, it is. So we'll now start reading chapter 9, and that's focus more on only on the test of hypothesis, one sample test for hypothesis for the mean. Homework assignment that you have to complete is homework 9, which is due on the November 30th. I made it. I can give you enough time so that you can complete it. Then classwork 8, which I will put here after the class is over. Test 2, completed by Sunday. I'm gonna try and put the practice text for you by Thursday or Friday. Then semester project. I'm going to show you where it is located. So for the semester project, if you log in, or for all of these assignments, when you log in, you go all the way to the models. Scroll down to the model 7, test of hypothesis. You see where the classwork will be. I will see the homework is there already. Test 2 is there already. Semester project, if you click on this, it will open up and you see the instructions. Follow these instructions religiously. That means you have to follow it word for word in order to get the credit, full credit. I have videos that you can watch where I did some examples for you. Now, for this project, you're going to submit 2 things: the Word document where you explain what you are finding, and the Excel document where you show all the work you did. Here, having explained that, I think we have enough information to start. Okay, today we are looking at the test of hypothesis. Hypothesis testing. Hypothesis testing is basically the give me 1 minute. Okay, is a hypothesis. A statistical hypothesis is a claim we make about a population parameter. That population parameter might be mean, variance, standard deviation, or proportion. So the claim may be true or false. We don't know until we test the hypothesis to find. So under hypothesis testing, we do the following. We define the population and specify the parameter, which can be mean or the standard deviation or the proportion. Then we state hypothesis that will be investigated. Okay. We state the hypothesis that will be investigated. Then after that, we choose the significance level, alpha, 0.05. If it's 0.05, that means your chance of your hypothesis being wrong is 5%. And if it is 10%, 0.10, mean that the chance will be 10%. Then we select a sample from the population, then we collect data on them, perform the calculations required. We then reach a conclusion. Now we can answer a lot of questions using this method, like questions like, does a particular medication lower patient's blood pressure? Um, does seatbelts reduce severity of injuries um, caused by accidents? Okay. Does the public does the public or customer prefer a certain color in a new line of fashion? These kind of questions might be educational, might be industrial, might be things like this. So we state the hypothesis, identify our claim, run the test, and either accept or don't accept the hypothesis. Okay. Now, there are two types of hypotheses we use when doing hypothesis testing. The one we call null hypothesis, which is basically a statement that the value of a population parameter is equal to some value. Okay. So it's a statement that the value of the population parameter, like the mean, are equal to some claimed value. We'll come to that when we start testing hypothesis. That will probably be on Thursday. I want to give you the background. So the sign we use for null hypothesis, the symbols we use are as follows: equal to, greater than or equal to, or less than or equal to. So the symbol for the null hypothesis must have some kind of equality on it. The alternative hypothesis says the opposite of whatever the null hypothesis is saying, and the symbol we use for it is right here, not equal to, greater than, or less than. So this means that you cannot use greater than in the null hypothesis. You cannot use less than in the null hypothesis. Okay. At this point, we're about to look at the type of errors that we encounter. There are two types, type 1 and type 2 errors. Type 2 errors, this one happened when we reject the null hypothesis. That is true. If it's true and we reject it, we committed type 1 error. And when it is false and we not reject it, then we have committed type 2 error. That's the kind of error that we can encounter. So let's look at some how to state hypothesis now. Look at that. It says, look at this, what we have on the screen. It says, state not an alternative hypothesis for each conjecture. That means each claim. It says there is such a thing that if expectant mothers use vitamin pills, the birth weight of the babies will increase. The average birth weight of the population is 8.6 pounds. To be able to answer this, first of all, it's still not an alternative hypothesis. HO is used for null hypothesis, and H1 for alternative hypothesis. Yeah. So this researcher is think that if expectant mothers use vitamin pills, the birth weight of the babies will increase. Means, and that we're told that the average birth weight is 8.6 pounds. Will increase means greater than increase means greater than. Now HO represents null hypothesis, H1 represents alternative hypothesis. So we increase means we're gonna need greater than right here. We cannot use that in the now alternative hypothesis. Okay. Right, let's see. Greater than 8.6 pound, 8.6 pound. Oh, I can use that here. Greater than can only be used in the alternative hypothesis. So mean, okay, is greater than 8.6 pounds, which is what he's claiming. That's the claim right there. So whatever the Monod hypothesis and the alternative, they say the opposite of each other. So that means the Monod hypothesis would have been mean greater than, or sorry, less than, right? 8.6 pounds. Now the problem is that we use less than. We cannot use less than here. We can only use less than or equal to. So I'm going to change to less than or equal to. If you have it, less than or equal to. Here, and that's it. You have stated the hypothesis. My hypothesis is okay. Now some textbook does do that this way. They they use equal sign for all null hypothesis. That is not bad per se. With equal sign. Okay. So now hypothesis. Okay. All right. See. Okay. Now and then alternative will just be. And I want to highlight it with a different color so you can know the difference. So some book will just put uh, equal sign for all null hypothesis and only change the alternative. Okay. Uh, Now, you can see how there's some books state it's still correct. Both of them are correct. Now look at this one. It says an engineer. Before I do this, any question in what I have done already? Any question? Can you hear me, guys?
Can hear you. Are you talking about, are we doing a classwork right now?
No, we're not doing the classwork. Not right now. I'm still teaching the concept.
Okay. All right.
Now, look at this as example. It says an engineer um claimed that the mean number of defects can be decreased. See the keyword right there, decreased in a manufacturing process for compact discs by using robots instead of human beings for certain tasks. The mean number of defective discs per thousand is 18. So decrease means less than. So let me just copy this and then put it right there. Okay. HO and H1. H1. Okay. HO and H1. Get that? Now I think I'm gonna make this disappear. Now H1. So he now told that the mean number of defects can be decreased. Decrease means less than, and you can only use less than in the alternative. So we have mean, when I insert it, mean less than 18. And that is the claim. So the opposite is supposed to be mean greater than 18, but because we cannot use greater than symbol in the null, we're gonna use mean is greater than or equal to 18. And that is you have stated the hypothesis. Okay. Now know that the null hypothesis is not, the alternative hypothesis is not always on the the claim is not always on the alternative hypothesis. It can be both ways. Let's look at this one, which is two-sided. Okay. It says here, a psychologist, feel that playing soft music during test will change the result of the test. It will change. It doesn't say whether it's increase it or decrease It say that it will change. The psychologist is not sure whether the grade will be higher or lower. In the past, the mean score, average score is 73. Okay, let's do it. Like I say, this time around, it doesn't know whether it will increase or decrease. It just say that it will change, which might mean that it can decrease or increase. We got HO, H1. I'm gonna onboard this. All right. So the psychologist feel that displaying some music during a test will change. Will change. That's the keyword right there. Will change. It doesn't say whether it's gonna increase or decrease. So you gotta be mean. You have it here. Mean will change. That means not equal to. Not equal to 73. Okay? Can say that the opposite means should be that it is equal to. Mean, okay, is equal to 73. So we change. This is where H1 represents we change. That means H1 is where we have a claim. Okay. So that's like now, if you look at the three examples, the claim is on the alternative for all of them, but not always the case. Let's try examples. One example, like this one here. It says the average annual income of accountants is 51,497. Okay. This one, the solution will be solution. So HO and H1. See, is means equal. So H1, HO, so HO means mean equals 51,497. Then alternative will be opposite. Mean is not equal to 51,497. Okay. Okay, let me see. This time. Got this person in. Be good. Okay. So you can see that the claim is here because you say that is and is it means equal, and equal can only be used in the null hypothesis. So you can put claim right here. So this time around, claim is on the null hypothesis. See? And you know that examples I have given so far is for the mean. We can still have proportion, like here. It says here, at least 45% of senior citizens, we are hearing 8. Okay? I hope we at least 45%. So because this 45% is a percent, so it's a proportion. The proportion. Yeah. So we're not gonna be using the mean, we're gonna be using the P. So P, according to this, at least means greater than or equal to, which can only be used in the null hypothesis. P greater than or equal to 45%, which is the claim. Okay, here it should be less than or equal to, but the problem is that you cannot use less than or equal to in the alternative, so you can just use less than. P is less than 45%. Okay. Any question on this?
Yes, Professor. What's the classwork for today?
When the class is over, I'll put it.
Oh,
So,
okay.
so I want you to pay attention so that because what some of the things I'll ask here is I did here is what you see on the classwork.
Okay. So it's gonna be based on what you're doing now.
What I'm teaching here today,
Okay.
yes. Okay, now, so I've shown you how to do it when it is a mean and when it is a proportion. Now, there are other type of questions I can ask in the homework, especially. For example, it has when you have the time, you can try these other ones. Um, when it comes to finding critical values, which we'll be using when we start testing hypothesis. But before we do that, I want to introduce you to some other concepts, which include the terms we use in hypothesis testing. The first one is the level of significance. The level of significance simply means the alpha. We call it the alpha. Otherwise, it means the probability of rejecting the null hypothesis when it is true. So if you're 95% confident, like we did when we were doing confidence interval, or if your alpha is 0.05, that means you have five in your test, you have 5% chance of rejecting a true null hypothesis. The formula we use to find it is the probability of type 1 error will give you the alpha, which is significance level. The critical region is the rejection, what we call the rejection region. If your answer falls in the critical region, you reject it. If it does not fall in the critical region, you don't reject it. And the critical value is the line that demarcates the rejection region from the non-rejection region. Now, the type of test we have, now at this point, let's look at the type of test we normally have. The one we call two-tailed test, whereby let me put it this way, we use it if deviations of the estimated parameter is in either direction from the benchmark are considered theoretically possible. Like here, because you can see the blue part of this, that's the tail. It has two tails. Okay. So if you answer fall in either of this blue region, you reject the null hypothesis. Otherwise, don't reject. If you can see how I put the line here, reject it. So this is the 1/3 test. 1/3 tests. The 1/3 test is when if only deviations in the one direction are considered possible. Like here, when you look at this, only the left side is shaded. Consider that when it falls in this non-shaded region, you don't reject. But if the answer fall in the reject region, you reject your null hypothesis. Okay. Now, the other one is the right tail. In that case, the tail is on the right side. If anything falls, if your answer falls from this, you reject. Or if it's not fall here, don't reject. Now, having explained that, we can now look at the critical values. Now you understand what is left tail, right tail, and two tail when it comes to hypothesis testing. Now, let me show you now how to find the critical values. So finding the critical values. Okay. Says this is the Excel formula. I have it here for you. If you, it is on the handout that I uploaded for you. When you go to your models for this week, let me show you why it is uploaded and make sure I've seen this. Okay, good. It's right here. Okay, here. Okay, so anyway, let's see how the question can be asked. It says here, find the critical value using Excel for each of these following. A left tail test with alpha 0.10. B, a two tail test with alpha 0.02. C, a right tail test with alpha 0.005. Let's find it. So let me write them down so I can go to Excel and get it out done. Yeah. I'm gonna write the critical values. A left tail test with alpha equals 0.10. B, a two-tailed test okay, with alpha equals 0.02. C, the right tail test with alpha equals 0.005. There are two ways you can do this. Either use a table or use Excel. Since we have already started using Excel, I guess it best needs to continue with that. So I'm going to take you to Excel so you can see how to find these Z critical values. Yeah, this one, I'm going to remove this one so that it not confuse us. Okay, let's do it. You see that here, alpha for this one is, you look at the question, alpha is 0.10. Okay. As a matter of fact, you can type all the alphas in. Let me just go and type them in. Okay. The one is left tail, 0.10. One is right tail, 0.005. Oh, excuse me. Other one is two tails, which is 0.02. So the command, as you can see from this chart that I put for you in the handout, you can see all the commands right here. For the zeta, you can see all of them, a second formula. Let me just write one of them, write some of them. Oh, I think I have it. I think I have it right written up already. I have it right here. So let's do it. Let's go and apply some of this formula to get these critical values. Okay. So the formula for this will be like let me put the formula on the screen. Formula critical value for A part. This is I wrote it down. Is it? Oh, right there. Left tail test with alpha 0.10. So because it's left tailed, for left tail with alpha is we use norm for left tail. I'm gonna write it right here. Use equals norm dot s actually norm dot inverse. Norm dot s dot inverse. S dot inverse. And you're gonna have put the alpha in, you know. Just the alpha, put the alpha in, and that's it. Press the enter key, that'll give you the answer. So the first one, left tail, the alpha is 0.1, so equals norm dot s dot inverse to pop out. Okay, we answer, excuse me, sorry. So this is alpha right here. So click on it, close the parenthesis, then press the enter key to give you the critical value, because it's left there, it's give you a negative number. For this one, it's on the right there. In that case, right there, let me write right there here. Right there. For right there. Oh, excuse me. Right there. So we're gonna use equal, just equal. For right there, num.s.inverse. Num dot s dot inverse 1 minus alpha. Then press the enter key. So that means from here means equals what's my distance? Num.s. Oh, I think that is num. I did put that. Num. Correct this. Num s dot inverse 1 minus the alpha, and the alpha is 0.05. 0.005, I mean to say. Press the enter key. See, 2.58. 1 minute. Let me check something here. Yeah, check something right here. Okay. Okay. Now, last one will be 2 tails. 2 tails. For 2 tails, let me expand this to 2 tails. Okay. Excuse me. 2 tails. You're going to use this equals num dot s dot inverse 2 tails. So 1 minus alpha, because it's 2 tails, that means 2 sides. So you got to be 1 minus alpha over 2. This is 2 tails. So that means here you're going to have equals num dot s dot inverse 1 minus alpha here divided by 2 and close parenthesis. And that should give you the critical value for that. So why would we need the critical value? Critical value is if your answer is equal to, when testing hypothesis, if your answer is equal to or greater than the critical value, you reject null hypothesis. Otherwise, you don't reject it. Yeah. So, any question on what I just did, guys? Any question? Hello, scholars. Does anybody have a question for me? Can you hear me, guys?
No question.
Okay, good, excellent. Now, so I have given you the background information about hypothesis testing. One more thing we need to do before we round up. That's why, because next class we'll be doing only the testing. So I want to give you the background. The one we'll be doing next week, on Thursday will be z-test for the mean. We'll be doing the traditional and p-value method, both of them. The process is similar, so that and the p-value we use it. For the p-value one, we use p-value as the criteria for making the final decision. But for the traditional method, we use the critical value for making the final decision. So the process is state the hypothesis and identify the claim. I showed you how to state the hypothesis. Find the critical values from the appropriate table, compute the test value. Then when you finish computing the test value, compare it to the critical value or to the p. If the answer is equal to or greater than the critical value, you reject it. Otherwise, you don't reject it. I wrote it down here. The criteria for rejection. It says reject null hypothesis if the calculated value is equal to or exceeds the critical value. And then with the test statistics we'll be using, I'm gonna bring this down, is this formula here. I'm sure you are familiar with this formula. Z equals X bar minus mean divided by the standard deviation over square root of n, but we'll be using Excel. So if you can practice how to do this with the formula. Where S bar is the sample mean, mu is the population mean, delta is the population standard deviation, and n is the sample size. So when we come back on Thursday, we start testing hypothesis, start from number 8. Now I'm going to put a classwork, part 1. You gotta do it in Excel, submit it tonight. Yeah, I can upload this video on it. I'll upload this on it so that you can see how to do it. Any question? We are closing early today. Any question for me, please, before we leave?
No questions.
Okay, I'm gonna make it available by 8 p.m. so you can finish it tonight, or you can do it tomorrow. Okay, I'm gonna put this video. You can watch it and see how to stay out what to do in the last work. Now, otherwise, I will see you guys on Thursday. We'll spend more time on Thursday. You have a nice day, guys.
You too, Professor.
You too, Professor.
Before you go, remember this week we start. So if your attendance is up to 70%, I would say wait till Thursday before you start making the request, so that I have 2 assignments I'm still grading now. So I can finish grading them. You can now see what your grade is before you can know which one to redo and request. If your attendance is not up to 70%, then you have to wait for it to go up to 70% before you can make that request. We have for now till the 7th of December. So I will see you then. Now have a nice day now.
Are you releasing classwork 8 now?
No, I'm gonna. It will be available around 8 p.m. today.
Okay, so when is it due?
It's due tonight, or if you didn't finish it tonight, you can still submit it tomorrow.
So you're gonna release it at 8 and it's due tonight?
Yeah, or tomorrow. If you don't finish it
Okay.
tonight, you can do it tomorrow.
Okay, thank you.
All right, okay.
And you said the classwork is basically what you did today?
No, that's why I'm saying I'm gonna make it available tonight. So
As a video?
Huh?
As a
Yeah,
video?
what I covered today.
Oh.
Yeah, you can watch the video and follow it and use it as a guide to solve the question in the classwork.
Okay, that's cool.
Yeah. All right, guys, have a nice night, evening or afternoon, whatever it is on your side.
When is the deadline to make up the work? Do we just send you an email
For
the makeup work?
no, let's after Thursday. After Thursday, the deadline Wednesday is for the classwork, not for the.
Are we in person on Thursday?
We are every Thursday. We are Zoom.
Okay, so what is the process to do the makeup work?
Yeah, if you check your attendance score, if it's up to 70%, then after Thursday you check the assignment that you failed. I can do 3.
Okay.
So you can now request for those 3 that you want to redo. So provided that your attendance is 70%, then I will reply to you and give you the makeup work.
Okay. All right. Thank you.
Welcome. You guys have a nice day.